Welcome back to our live training session here. We're going to be taking a look in this tutorial at dialing in our full throttle tuning on our low cam or non-VTEC of operation. Now this tuning process is very specific in the order of operations we want to perform it for a Honda K-Series engine. We have VTEC and we have variable cam controls. We have two different layers here that are going to add a bit of complexity to our calibration strategy. Now we're only focused on dialing in our low cam or non-VTEC operation, but we do have variable cam to account for. So let's jump in here and talk about what we need to do in terms of the order of operations for calibrating and tuning, and then we'll talk about setting up our mainline dyno here to do our full throttle pulls, and then we'll start our tuning process. So the first thing I want to go and do is jump into my laptop screen right now. I have the EMU Black software open. I have our last calibration file open from our previous tutorial doing our part throttle tuning. So we have our VE table nailed down from about 40-50% throttle and below. We are tuning in an alpha end strategy, so we have throttle position as our load input to everything from our target lambda table, VE table, spark timing table, and variable cam control table. With the individual throttle bodies, we want to map things based on the throttle position rather than map pressure sensor because we have a much more reliable means of a load input to calculate fuel, spark, variable cam control. So alpha N is definitely the way we want to go. And we've calibrated everything below 40 to 50% throttle. So everything here, 40-50% throttle is 100% nailed down. So we're going to be taking a look at our last essentially quarter of operation of our table. This is all for our full throttle. So taking a look at this, we need to go in and dial in our VE table when we're at our 0-degree variable cam angle. So this is going to be our essentially our baseline of where we're at. Now, a few things with this. We've went into our variable cam control, so if we jump into our cam page here, we're going to find that in our cam 2 angle 1 target table, anything from 60% throttle and higher, we've zeroed out the variable cam target. This allows us to kind of get a baseline with no overlap on our engine and to be able to sort out our VE table and get that nailed down in terms of our fueling to make sure that's 100% correct in terms of the airflow representation. This allows us, by having the variable cam here at 0 and dialing in our VE table at 0-degree cam angle, to then walk up our cam angle target from 0 to 10, 10 to 20, 20 to 30, and watch what's going to happen to our fueling. If you don't have a chassis dyno, you can get a very good idea if the changes you're making in your variable cam control table are going to be a positive or negative change based on what our fueling is doing as we're examining our data logs and taking a look at what our lambda correction is doing and comparing our actual lambda to the target lambda. We're going to get into all of that, but we've went in here specifically and zeroed this out. So what we're going to do here is jump into the VE table and get this nailed down here at our 0-degree variable cam target. Now, the other layer of this, the other aspect of this is our spark timing. In our spark timing table, we've essentially said from 40% throttle and below, the spark timing that we have in here is adequate. We've reached maximum brake torque below that. Above this, we have pretty conservative spark timing here. We're at 12 degrees of spark timing. Now, this is probably about 10 degrees less of spark timing than where we need to be at for low cam to make adequate power output out of our engine, but we're doing this very specifically. We want to make sure that we're able to run the engine with no knock or pre-ignition when we're doing our full throttle tuning, and that's going to allow us to dial in our VE values in our table here, so our upper portion of our table, the last quarter of our table, get these values dialed in, and then we can proceed to move on to dialing in our spark timing. However, if we take a look here, we have our knock control to set up. I have the OEM knock sensor fitted to our engine, and we need to go set this engine noise or the knock threshold table up. That's going to tell the EMU that anything below whatever the voltage here is in the table, it's going to consider it to be engine noise. Anything above that considers it to be knock. And if it starts to knock, then it's going to start to attack that and pull some timing or add fuel, depending on how we have things set up in our knock sensor action window here. So we're going to be getting into setting this up, but by having a low spark timing in our spark timing table, it allows us to get a knock threshold table built. So the profile, the output of the engine, the output of the knock sensor, when the engine is a no knock condition. We can't set this up if the engine's knocking. It won't be reliable. So we kind of have a two-part effect the way we've set our spark timing table up. Now, once we've dialed in here at 0-degree VTC, again, once we've dialed our VE table here, we're going to go into our cam target and walk them up from 0 to 10, 10 to 20, 20 to 30, 30 to 40, and we're going to see the effect it has on our torque output and our power band of our engine. Then we're going to be building a cam composite blend at full throttle to be able to account for the best torque output out of our engine. So this is going to be something that it's going to take a couple steps to build out, and then once we build that blend, at that point, when we go in and we have that that blend table mapped out. We're able to go into the VE table here and then touch this up. As we add more overlap in and we gain more torque and horsepower output out of our engine, we're going to be actually having more cylinder pressure, moving more airflow into our engine. If we have more airflow, we need to have a higher expression of our volumetric efficiency to tell the EMU that we need additional fueling, so we're going to have to raise our VE in those specific areas. We are not going to touch the VE table run to run, so we're just going to go ahead and try our cam targets and seeing the effect it has on our power band, allowing the EGO correction to clean up whatever the difference is going to be run to run. And then when we finally have the cam composite blend, then we'll come in here, touch up the V table 100% so it's dialed in at that cam composite blend. And then at that point, we can move on to doing the spark timing. And that's going to be the last thing we take a look at. As we change the overlap, as we change that cam target of our engine, that is going to change the knock tolerance of the engine. So we'll find that if we have a completely different variable cam target, the engine might knock on one variable cam target and not on another. So we want to make sure that that variable cam target's 100% nailed down. The last step is going to be setting up and working with our spark timing. So order of operations, dial our VE table in at 0 degree, walk up our variable cam, build out the cam composite blend table, then go in, touch up the VE table again at the cam composite blend table, again having that best torque. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.